Hi, it's Miss Cantwell. It's Tuesday, the 21st, and we are going to talk a little bit about lenses and mirrors and then a little bit about diffraction. But before I get to all of that, I would like to talk about grades and quizzes and things. So it's important for you to kind of understand. So there's two different ways you could be learning this stuff. One is through Edgenuity. This is what the district wants you to use if you have internet at home, if you have access to a laptop at home or another PC or Mac, I guess, not discriminating. If you have these things, the district is expecting you to use Edgenuity, and you get to that through my.cfisd.net. Okay? Now, a few people don't have access to those things, or at least don't have access to them reliably. So they're going to be utilizing the packets on the Learning at Home website. This should not be you if you have internet and you have a laptop or something that you can access. Okay, but you can get the packets from the website. You can get them from the school. Will either mail them or in some cases deliver them to you if that's what you need. So if you need the packet, I need you to let me know, okay? Because that's how we make sure we can get it delivered to you so you don't have to worry about printing it, finding a way to get it, anything like that. But like I said, the majority of you will be in this Edgenuity. So that means when it's time to take your quiz, there's two quiz links, okay? One says Edgenuity, and the other says Packet. If you learned through Edgenuity, you did the lessons on lenses, mirrors, and diffraction, then you need to take the Edgenuity quiz. If you did work in the packet, that packet is a couple weeks behind. So right now in the packet, it's wave behaviors, interference, standing waves, things like that. So if you're working through the packet, then you need to take the packet quiz. These aren't aligned with each other, right? They're only aligned to whatever method you use to learn it. Okay? So if you have questions, you only have to take one quiz in Google Classroom, either Edgenuity or the packet, and it depends on which one you use to learn the material. Also, the modules in Edgenuity are not going to be graded. Only the quiz in Google Classroom is going to be graded. And if you have the packet, there's nothing that you need to turn in. Okay? Let's go back to desktop. Maybe. There we go. All right. Oh, no. See, I can't work it at home either. All right, so before we talk about mirrors and lenses, I want to kind of skip to images, okay? So images happen when light rays line up a certain way, okay? So the image can be upright, so that means like if this is my object, a lot of times we'll use an arrow. Upright would be the image would, be right side up. Inverted, the image would actually be upside down. Okay? It can be in front of the mirror or behind the mirror. So real images appear to be in front of the mirror, which means that there's no space between the object and the mirror in the image. Okay? Virtual images appear to be behind the mirror. So the best example I can think of is in your bathroom mirror. So like this is you. Looking great today. Here's your counter. Here's your mirror. Okay? When you see your reflection, you also see the counter, right? So that means that your reflection is the same amount of space behind the counter as you are. Okay? So that would be what we call a virtual image. We can also have objects that are larger, smaller, or the same size as the object. And all of that depends on how the light rays are reflected off of the mirror. Okay, so mirrors reflect light and that helps us form an image. So this is a plane mirror. This is a flat mirror like what you might find in your bathroom. Your eye is here. This is the object. So if you look at this angle, we learned that the law of reflection tells us that the angle of incidence has to be equal to the angle of reflection. So we see this light source, but we see it as if it were behind the mirror. Okay. Plane mirrors are going to produce virtual, which means behind, upright, which means right side up, and the image is going to be the same size. Your plane mirror, your bathroom mirror that's hanging on the wall, the flat one, is not going to magnify your image. In order to magnify your image or reduce the image size, you have to have a curved mirror. So the only curved mirror that we will really talk about is a concave mirror. Concave means that it's caved in. Okay, so this is the part of the spoon where the cereal sits. Here's some Cheerios. Okay, it causes light to be, when it reflects, when it reflects here, it's gonna focus back onto a single point, which is called the focus. Okay, all of these light rays are gonna come together at that single point. Okay. These curved mirrors can make images that are larger or smaller, or real or virtual, upright or inverted, and it all depends on where we put our object. Okay, is our object here? Did we decide to put our object here? It all depends. Okay, and I'll show you examples of that in a little bit. So let's talk a little bit more about real and virtual images. Real images are produced by converging light rays. So if we go back to this mirror, this curved mirror, these rays are all headed towards the same point, and they're going to meet up at that point. So this is called converging light rays. Okay? Now, these can be projected onto a screen or a surface, which is interesting. If you can get a good enough quality image on the inside of your spoon, you could actually angle it so that you'd be able to see that image on the wall. If you're able to do that, or if you have a caved-in mirror at home and you have an example, feel free to upload it. Virtual images are produced by diverging light rays. So they're rays that appear to be moving away from a single point. I'll show you an example in a minute. These can't be projected, and it'll look like it's behind the mirror or behind the lens. So let's talk about lenses. Basics. So the mirror uses the properties of reflection, but the lens is going to cause the light to go through a different medium. So that's going to utilize refraction, okay? Because it's bending the light as it goes through the medium. So most lenses used to be glass. That's why we call them glasses. Now they're mostly some sort of plastic that's kind of hardened and scratch resistant, or a very, very thin film in the case of contact lenses. Different shaped lenses can either cause light to converge or diverge. So if we look at this top one here, okay, this one, we've got converging lenses. Okay, we've got light rays that are all focused together at a single point. On a concave lens, okay, they diverge. That means the light rays move away from each other. So instead of moving at a point where their ray would continue back to the focus, they're going to point, the actual ray is going to point away. Whoops, that's fun. Okay, so there is, I know in the videos they did a lot of ray diagrams and calculations and things. We are not going to ask you to draw ray diagrams for us. We may ask you to predict where an image would be and what the qualities of the image are. So there is a really useful tool. It's an optics bench. It's made by physicsclassroom.com. I'm going to also attach this slides presentation to the post where I share the video so that you have access to it, but it's one of my favorite things. I really like ray diagrams because I like rulers and straight lines, and I teach physics and I'm a nerd, but that's okay. So I am sad that I don't need the directions. What is this? I'm really sad that I don't get to share this with you, but we can do it this way. So I'm going to expand it, maybe. All right, here we go. So you can see we can change this from lens. This would be a mirror, okay? And the only one it does is that concave mirror. That's the only one we're really going to talk about. So we can change the focal point of the mirror. Notice that the focus is moving. Let me turn these off. The focus is moving back and forth, okay? We can change the height of the object if we want to. We can make it an arrow. We can make it letters, okay? Whichever one we want. I like the candle. So I'm going to put my focus back, or try to. Okay, that's where it's staying. And I'm going to bring the height of my object a little bit so we can use the grid lines. Okay, so we can see that if we move our object, this thing on the top here is the object, and this little tiny candle at the bottom, we know that that's our object because if I change the height, the object is here, okay? And the light rays would come off of the candle and bounce back. So I can move my candle. I can see that if I put it at the 2 times the focal length, which is also called the center of curvature, they are really close to the same size, just the image is inverted. If I go between the center of curvature and the focal point, the image is inverted but much larger. And if I hit the focal point, the image is actually going to disappear. And we know that because these lines, these rays that we would draw are parallel. And if they don't converge anywhere, then there's no image that's going to be found. Okay, so you can play around with this a lot. If I move the candle in between the focal point and the mirror, then I get an image that is upright and behind the mirror, so a virtual image. You can also change it to lenses. You can look at converging and diverging lenses if you want, and you can do the same thing. So if I put the candle on the 2F, or the center of curvature, the image is also at 2F, the center of curvature, and they are exactly the same distance apart, and they are very close to the same size. The only reason that this one, the image height is negative, is because it's an inverted image. And we can move the candle, and we can see what happens. If I put it on the focal point, again, I'm going to have these rays that are never going to converge, so it's going to disappear. And then it gets larger. And then diverging rays, we can still move it. So you can play around with this and kind of see. You don't have to be able to draw the ray diagrams, but you can see how the positioning of the object affects the image characteristics. Okay, let's go back to this. So the last thing they have you talk about is diffraction, and it's kind of a weird fit, but it is a wave behavior. So we talked about reflection, which is bouncing back, and now we're going to talk, and we talked about refraction, which is changing media. Diffraction is when it bends around obstacles or through openings. Mechanical waves are it's very obvious to see that. So with sound waves, you know that you can be in the aisle across from your friend at Target. You can't see them, but you know that if they yell your name, you can hear where it's coming from. Kind of like Marco Polo, right? They don't have to be right in front of you. They can be behind you and you can still hear them. That's why obstructed seating at concerts is a thing. So you won't be able to see it, but you can definitely hear what's going on. With light waves, it's kind of the same thing. You know that your mom and dad's light is on in their bedroom without actually being in their bedroom because you can see the light bending through the door. So light can do this too. So we can see here there are several things that affect how much it bends. So this top row is talking about the opening that it's going through. We can see that as the opening gets smaller, Okay, there's much more bending. We can also see that as the waves are farther apart, there's more bending. Okay. They talk about a lot of math with this diffraction. We would not talk about that normally, so we are not going to assess you on that math. So I hope that that information makes you feel a little bit better. We are just going to ask you questions. Like diffraction, you need to know that it's bending through an opening or around a barrier, that it doesn't have to do with the change in media, and it's not bouncing back. Okay, you might pay attention to the wavelength size and the opening size as well. Okay. With light, it's kind of cool because different wavelengths bend different amounts. So that's why we can shine light through a prism and get a rainbow on a piece of paper, because the different wavelengths of light will bend different amounts. The longer wavelengths of light are going to bend more. So if we think about our rainbow, maybe red, orange, this is taking more time than I meant to, yellow, green, blue, and violet. Indigo is a lie, more on that, ask. Okay, so these are all going to bend different. So the ones that have the longer wavelengths are the lower frequency. So that means that red waves have higher wavelengths, so they're going to bend the most, and so they will. That's why they go in this order, because it's how they bend through the opening. Okay. In real life, we can use diffraction. There are things called diffraction grating lenses, which have itty bitty slits in them. You can't see them. They're so small that you can't see them with your eye. But if you hold them up to your eye and you look at a light source, you can see rainbow and different wavelengths of light. And there are also devices called spectrometers, which are used in everything from chemistry to identify chemicals or substances, into astronomy to determine which range of light waves we're seeing that's being emitted from a celestial object. So those are both examples of how we use diffraction of light to tell us about things that exist in our world and in our universe. So here's the spectroscopy. It's the analysis of light by splitting it according to wavelength. So they're going to use a spectrometer. Basically, you have an emitter. This is an object. It's going to bounce off of this sample. And then we're going to be able to see, based on these peaks, what exactly our emitter is or what it contains. Okay? So that is all that I have for you on this unit. I know that there's a lot of math and the ray diagrams seem confusing, but I just want you to take some deep breaths. Remember that we know that we are not here in front of you, and that this stuff might be challenging to learn on your own, so we're going to ask you big ideas. And then remember also that we have unlimited attempts at this quiz. So you can try it as many times as you want to get 100. You don't have to just quit after 3 or 4 or 1, okay? So you have as many tries as you need to get it right. And then also, I don't have information about GP4 yet. As soon as I do, I'll let you know, okay? As always, if you have any questions, please feel free to ask Google Classroom, email, Google Classroom. Those are the ways you can reach me, okay? Your parents can email, you can email, whatever we need to do. And if something has changed at your house and things aren't going the way they normally do, just go ahead and let me know, and I'll try to do what I can to help out, okay? We're all going through this at the same time, right? So it's best to be kind to one another and to do what's best for ourselves and the people we care about and others, okay? I miss you. I'm so sad that I'm not going to be able to see you again before the end of the year. But if you need anything, I'm still here for you, I promise. And I still think about you guys all the time. Okay? So I hope you have a great rest of your day. And I hope that you're able to find some time to do some things you enjoy as well. All right? I'll talk to you later. Thank you so much for watching.